Naturally, I wanted to design my own flying saucer. Come join me. To begin with, I would define the flight profile and flight regime my saucer would fly. I would have it directing its lift/thrust down its center axis, like a rotorcraft or powered lift VTOL aircraft. That way, when it flies horizontal, its disc wing would be at a slight negative angle of attack, much like a helicopter rotor's plane of rotation. With this configuration, where the saucer develops lots of thrust and acceleration, it'll most likely fly face first instead of edge on, the same way a rotorcraft can when getting up in a hurry. Flying face first rather than edge first might seem aerodynamically counterintuitive. Why choose the high drag facing and not the low? And normally that would be correct. What's different about my saucer is that the mechanism for lift and therefore thrust takes advantage, or is supposed to take advantage, of the Coanda effect, intaking as much air as possible from the front/top surface of the disc wing and ejecting it at the rounded edges, where the air follows the curve below to increase pressure and make the pressure difference necessary for flight. As for how to get enough air from the top to the edge to the bottom, I took inspiration from Coanda's patent and figured a radial arrangement of turboshaft engines driving multi-stage centrifugal compressors would do the trick. They'd have to fit in the thickness of the disc after all, so there's not a lot of room for lengthy axial compressors. And they'd have to be pretty durable for their size because it wouldn't take much failure in thrust and control to send my saucer tumbling. Then it would be a Greek saucer. Moving on, I mulled over whether each turboshaft engine should have its multi-stage compressors topside, or both top and bottom. Having air drawn from the bottom would help aerodynamically by removing static air that contributes to drag in the face-forward flight profile. Instead, I decided that the engines should be mounted vertically, low in the center disc, multi-stage compressors above, and leaving room for the next component. Again, taking inspiration from Coanda's patent, I decided the compressor outlet should end in a thrust augmenter, which takes high-speed airflow and entrains even more air from outside to increase thrust from a larger mass of slower-moving air. Thrust augmenters are less efficient the faster the ambient air comes in, but for a saucer flying face first, drawn from air that would otherwise have to make a hairpin turn to get around the saucer might mitigate the drag. Once the air increases in mass flow and pressure, it should be gathered in a circumference plenum so that it can distribute itself to the ring of ejector flaps that would direct the flow for thrust and control. This is where a disruption in airflow to different parts of the disc would be a problem. The circumference plenum is one part of the solution. The other part is the distribution of engines and compressor assemblies. The challenge is to take available engine shaft power and turn it into as much mass of airflow as possible. It's analogous to how a turbofan is most efficient when its bypass ratio, fan thrust to jet thrust, is as large as possible. That's where I saw an opportunity. Instead of a brute force solution of cramming as many engines as possible into the disc, I figured I could turn a more sensible number of engines into a larger array of compressor augmenter assemblies with mechanical cross-shafting. Some power would be wasted per engine, but the extra airflow should make up for it. 3 turboshafts, each directly powering one compressor assembly each, plus 3 more via cross-shafting. Now, if this configuration works, and don't be too sure it would, the power of the turboshafts will provide substantial lift and thrust under fine control from numerous rim-mounted ejector flaps, and with some redundancy between 3 engines and 6 compressors cross-shafted to each other. This leaves room in the lower half of the saucer for fuel and payload, with the pilot comfortably in the center. Don't expect room for a death squad, though. This would probably be cramped. Any resemblance to the design philosophy of a Ford trimotor is entirely coincidental, but still welcome.